All right, onward and upward, onto the forward scrub for the file system.
All right. This is an interesting blueprint because unlike all the other blueprints we've done, we actually took time to I mean, I don't know that we did a great job, but this is actually a thing we talked about a year and a half ago, and that we actually sat down and created tickets for and even made time estimates on those tickets for. But we've never had a blueprint on it
Look at that.
because it preceded the blueprint concept or at least our CDS sessions, and we haven't worked on it since that started. So forward scrub is the first of two parts that we would like to implement for a distributed CephFS check system. The concept here, the very basic concept here just saying, okay, we have a running file system and we want to start at the very root node of the file system hierarchy and go down and look at everything we can touch from that node or from the root of the file system and make sure that everything in it is consistent with what we believe the case is based on metadata. And the second part, which we're not going to talk about in too much detail right now, is going the other direction where we say, okay, let's look at all of our Rados pools and enumerate the objects in them and make sure that all of those objects are attached to the file system. And if they're not, then we want to repair them. But we're just going to talk about going through the file system metadata and then looking out and making sure that that's consistent with itself, and then looking out at the Rados objects that the files point to and making sure that they're consistent with what the file system gives us.
And making sure the backtraces are accurate.
Yeah, make sure backtraces are accurate and that we don't have a reason to believe that the file lengths are right, and I don't remember what else we can check, but certainly those two, and that the links between directories are accurate. It's an opportunity to recalculate the statistics we use for our recursives for our R stats and make sure that those are all good and things of that nature. So we have a high-level design, including several tickets to work on. And I mostly just put this in here because I wanted to give people the chance to talk about it. I know John was out here for a couple of days this week, but is unfortunately in an airplane right now, so he couldn't be here. And he was pressing for more details on some of them, which we talked through. But
do you want to just walk through the high level?
Yeah. Okay.
Approach, because I'm trying to refresh my memory how this was intended to work.
Yeah. So
you have.
I mean, it's written down, but I can walk you through what's written down.
Okay.
So at the end, what we want to have is a separate scrubbing thread in the MDS that just runs along. And it's possible this will actually be implemented as our normal like series of callbacks or whatever. But conceptually, we have a scrubbing thread in the MDS, and this scrub begins in a scrub inode function. And then and we maintain a stack of inodes that we want to scrub. And then in scrub node, we start by getting by setting a scrub start stamp on that inode, which just says, okay, we've started a scrub at this time, and setting a scrub start version on the inode, where that version is apparently the parent of the version of the inode's parent. And then if it's file, it's easy. We just look at the, if we optionally, we probably might configure what the thread spins off an async chunk of the backtrace, and then sleeps until that comes back and does a finish scrub on the inode.
Is it actually doing these? These are writes that it's journaling, like updating these fields, or is this just like a
I think these need to be writes because that's how we provide guarantees about when the last time the system was scrubbed as a whole.
Okay.
Because you want to say, okay, we've scrubbed everything, or the oldest thing that was scrubbed 2 weeks ago, and the newest and everything has been scrubbed within the last 2 weeks.
And you know that this subtree was scrubbed cleanly, 3 days ago or something like that.
Yeah.
Yeah. If the scrub end stamp is set, right? Okay.
So, but then if it's not a file, and then it's a directory or a dir fragment that we need to walk through. So, shoot. Oh yeah. So then our start scrub on that dir frag will verify that the parent data matches the aggregate data of what the directory contains, and then it also sets then it sets those scrub start stamps and versions, and it pops the inode off of the scrub queue and checks if the next thing up is the inode's. Wait, hang on a minute here. Ooh. Wow, that is not very clear in this presentation or in this writing. Anyway, so if it's a dir frag, then we put it on. Then we want to put it on the top of the stack and add all of its child nodes to what we call the scrub stack. And so basically what's happening is we're doing a depth first search of the tree and going down and then scrubbing all the files at the bottom and saying, okay, those match the directory that contains them, and then we pop up a level and then we say, okay, is there anything else we need to scrub in this level? Yeah. And then once the finished scrub is finished, then you mark a scrub finish stamp, so you can say, okay, this was scrubbed between everything underneath this tree was scrubbed between these times and it was valid.
So what happens if we hit a so that works if with primary inodes entries or whatever. Yeah. What happens if we hit a remote entry?
So what we've described so far is that we send off a scrub request to the MDS responsible for that tree.
Or yes, that's okay for a auth delegation for a directory, like a subtree boundary. Yeah.
So otherwise,
stepping back a second.
Go ahead.
Sorry, stepping back a second. If you just still assume a single MDS system, if it's a remote de-entry, meaning it's a hard link.
Oh. Yeah.
Like we basically have to verify that A, that the inode exists, and B, that the link count is ultimately the thing we need to verify is the link count is correct. Which we won't really know until we.
Through. Yeah.
I think, you know what, actually? I think the way to do that is probably to make it so that any inode that has a link count more than one, all of the remote links have a backtrace to where the thing is coming from.
Yeah.
No, because we don't want to update those when you're
I have a ticket to make lazily updated backtraces, but we don't want to keep them consistent. Yeah.
Yeah. There needs to be some way to identify what the sources are.
Yeah, so I guess probably what we want to do then is, in that case, then we want to maintain a thing that's like a list of them that says, okay, I scrubbed and I'm a remote link, and so I'm telling this remote inode that I have a link to it right now as of this scrub time and version for me. That's going to be tricky to maintain, but that'll be really tricky to maintain in the case, because scrub will be running while this file system's new. So if those scrub counts change, or if those link counts change, that'll be tricky. We might need to do something like
sketchy.
Oh, yeah.
Sorry. I guess the sketchy thing for me about this is that the process of scrubbing is like dirting every single inode of the system. Right.
Only the directories. Like
if we're setting just all these scrub timestamps and everything.
Yeah.
I wonder if it would make sense to have a mode where we just do it in memory.
Well, I guess I'm.
Like until if there's an inode that we visit and we set the scrub start version and we haven't finished the scrub for that, we essentially just pin it in memory. And it's a depth first search, so it's really just the ancestors.
Yeah. So I guess that what I would say to that is that we're still we're actually going and touching it all, whether we write to it or not. And if you aren't doing writes, then you can't make any guarantees about when things have been checked. And I think we could make it an optional thing where we don't do it. It's just I think that for any if you actually want scrubbing, then you care about it. And you want to be able to see those guarantees.
So maybe the optionally when you finish the scrub for an nano view, you update it that says I scrubbed it as of this time or something like that.
Yeah.
It might actually even be easier to implement in the first time around if it's just, well, no, probably not, but at least certainly be faster. I guess the main thing is that if
we worked through this pretty carefully at one point, and I think all of these timestamps were actually necessary.
Well, they definitely are if you want to tolerate failure while you're scrubbing. Like an MBS restart or something.
Yeah. I sort of assume that you're really only going to be doing one write to the stuff because I don't think it's likely to fall out of the journal while you're doing it. You set a scrub start stamp on it, but probably you're going to, except for the ones very high up in the tree, you're going to come back to it before that's done.
Yeah.
And it's going to be pinned anyway, so you won't be flushing it.
But at the end of the day, you're basically every directory will have been completely rewritten because every inode will have been dirtied. And when you flush out that directory in one big OMAP operation or whatever, it's going to be, which might be a good thing. It'll sort of defrag your metadata at the same time.
One option is to not maintain these on. We could, for instance, not maintain them on the files and only on the directories, and then there's a lot less of that activity.
Yeah. Probably.
But then you don't have any confidence about when all of your inodes were scrubbed. I mean, you get some. I guess the directory. Anything that was in the directory prior, or anything that has an M time prior to the scrub start stamp was scrubbed. Yeah.
So that's probably good enough.
Yeah.
Okay. So the first is a function to do data for a single inode. Scrub stamp the restriction. Let's just scrub a single folder. Blocking scrub. Where basically anything that's in the process of being scrubbed, you can't modify it.
Yeah.
Like if you have intervening.
Yeah.
How does the non-blocking one happen?
Carefully.
Okay. Simply abort the scrub.
I think that's basically what it's going to be. Is that with the advantage of the blocking scrub is that you can keep all of our normal locking primitives and stuff, and then for a non-blocking scrub, you're basically just going to need to throw out any results from during the conflict, which I think is a feasible thing to do. Although I also think we made that one of the tickets that we expected to take quite a long time.
Yeah. Do we score these?
Not in the we have scores somewhere, but apparently not in the tracker.
No, we didn't. No.
Well, we do actually have scores. Yeah. They're just we didn't put them in, or we have time estimates or something.
Yeah, they're in hours or something. Yeah. Yep. Okay. Okay.
Anyway, I think this is probably the next big thing I'm planning to do. I'm looking forward to it. It should be entertaining. Get sort of a data integrity feature that I know some people are worried about into the system. Yep. So we've been talking pretty technically about this for 19 minutes. Anyone have any questions or comments out of our 9 viewers at this hour?
Scaring them off. John, does this make sense?
Yes.
Yeah. Okay. Yeah, I mean, I think that the main thing that strikes me, having not thought about this in a long time and coming back to it, is that it does seem like, I'm not sure it's going to be more or less complicated. I don't think it'd be significantly more complicated, but it does seem like being able to do the scrub without actually persisting the stamps optionally would be a good thing. It means that you have to pin them in memory, but we probably have to do that anyway, just because. Well, they would already be pinned because it's an ancestor, so they're by virtue of the way that they're already pinned. But that would otherwise it's like but it'd basically be an option whether or not you're gonna update the undis scrub last scrub stamped or whatever for every inode. And that might be, I think that might get messy once we start dealing with like subtree migrations that compete with this, but until then at least.
We can definitely look at that. I'm afraid I don't remember how those interact in all the important ways to talk about this.
I'm thinking that it might even be that the very first like prototype of this, like you just skip the part where it persisted, and it probably might even be easier. Right? Maybe. Well, I don't know. Whatever.
It's not that I think you're wrong, as we spent a lot of time thinking about this a while ago, and I don't.
Yeah.
And I know there were reasons for all of it.
Yeah. Okay.
I think you're right, and I think probably we can just make it a simple config, like a simple if on a config switch. So I'll definitely look at that, but I don't want to commit to it.
Yeah. Of course. Cool. Okay.
Because I do see the advantage of being able to like run the expensive one on a monthly basis and run the best effort in memory one every night or whatever.
Well, I think also like the final UI or whatever is going to be something like do a fast in memory scrub, do a memory scrub where you mark directories, do a scrub where you actually validate every file's backtrace or not. Maybe just skin the namespace. Maybe you also look at the file blocks to make sure the size is correct. Like there can be varying levels of work that you do. And naturally at the end of the Teuthology runs, we'll go and we'll scrub everything and hopefully catch bugs in the process. Yeah. Okay.
All right.
Get us to the end of that one, does it?
I think so.
All right.
Yeah.